word problems.
Usually really
Word problems.
Hey, look at this 600 people. Oh, I'm done. We did these all. I'm done.
Okay. So, all right. So let's start with 4.8. 4.8. Solving problems using trig. A couple of definitions, quick definitions. Angle of elevation, angle of depression. So if this is horizontal, angle of elevation will be looking upwards, right? So the angle from here to here would be angle of elevation. If you're looking down, it's angle of depression. Angle of depression. Okay. So just a couple of quick notations there. Okay. Jump right into it. Example number 1. We have an example of angle of depression. Angle of depression of a buoy from the top of lighthouse, 130 feet above the surface of the water, is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. So the lighthouse was 130 feet tall. 130 feet tall. Angle of depression from here down. So from here down, this was 6 degrees. Okay, and you're trying to find the distance from the base of the lighthouse to the actual buoy. You're trying to find x. Yes?
So I'm going to try and solve the problem. Is it safe to assume that the angle at the very top and 6 degrees is complementary?
Yeah, this angle here. This angle here?
Yeah.
Is that what you're talking about? Yeah. So,
Is it complementary?
is it?
I don't think so.
Why not?
It's too small.
What's too small? This is not drawn to scale. Is that what you're asking?
No.
This is not drawn to scale.
Oh, I see.
Yeah, so you're correct. This is 84 degrees, right? Which makes this guy here what? 6 degrees again, right? Because these two have to add to 90 because this guy here is 90 degrees. Okay. So I know I have these two. I have this angle. So I have tangent of 6 degrees here is going to be equal to 130 over x. So x is going to be equal to 130 divided by tangent of 6 degrees. A word of caution here. When you do this, you need to make sure that you're back into degrees because it's 6 degrees, right? Your calculator should be in radians, right? So make sure that you're back into degrees when you do this. Okay. You should be able to just calculate that out. And it's going to be 1236.9 according to the book. Okay, so this is one of the simpler ones, right? Pretty simple. Not a whole lot going on here, really. Okay. Next one is example number 2. Example number 2. We are going to have, from the top of a 100-foot tall building, a man observes a car moving towards the building. If the angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far does the car travel? So I have a 100-foot tall building. So this is 100 feet. When I first saw the car, my angle of depression was 22 degrees. And the second time I saw the car, it was 46 degrees, which means that this guy here is 22 degrees. This guy here is 46 degrees. Question is, how far did it travel? It traveled from point A to point B, right? So I'm trying to find this guy here, X. Okay. So there really is no tangent cosine that I know that's associated with just X, right? Everything I know is the right triangle, so it's the right triangle. So it'd be if I call this guy D, You'd be associated with a D, right? In other words, the tangent of 22 degrees is going to be equal to what? Tangent of 22 degrees is going to be this guy over this guy. So it's 100 over x plus d. Okay. And then I have from this triangle here, I have tangent of 46 degrees is going to be equal to 100 over d.
So you solve for D first, right?
So I could do it either way, right? Okay. So let's go ahead and do the trick that I taught you how to do earlier. So I'm going to get what? 1 over tangent of 22 degrees is equal to 100 over x plus d. You just flip them over, right? Multiply 100 on both sides. That guy goes away. And I have x plus d. Correct?
Correct.
On this one, I'm going to flip this one also. 1 over tangent 46 degrees is equal to d over 100. Again, I'm going to multiply it by 100 on both sides. And d. Right? Now I'm just going to go ahead and put the d, this d in, put it into here. I'm going to get if I 100 over tangent 22 is equal to x plus 100 over tangent 46. So x is going to be equal to, if I can just move it over here, right? X is going to be equal to 100 tangent 22 degrees minus 100 tangent 46 degrees, right? I'm done. Okay. You can do it the hard way, which is the book way. I think the book is, yeah, x plus 10. No, where is it? It's over there. Is that the same way? They do the same thing we did? Oh, they did the same thing we did.
Yeah.
Yeah, they did. They did okay. They did pretty good. You understand what's happening, right? Okay, good, we're good. All right. Again, this is a little more complicated because you actually had to come up with, this is, I have to put this into D, right? Which they didn't tell you. You had to be able to figure that out, right? I could have also asked you, okay, so if once you calculate x was equal to 150.9, and I could be really mean and I could ask you, if this happened in 15 seconds, how fast was the car traveling? Right? Then I would just divide this by 15 seconds, right? But it's one more step you would have to do, right? Okay, so I could have asked that. Also, I could have not given you this. I could have given you this. And then you could have had to find this guy. Okay. Several different variations to this problem is what I'm saying. Okay? Right. So example number 2. Example number 3. Basically the same problem. This is a variation of that problem. Okay? A large helium-filled penguin is moored at the beginning of a parade route awaiting the start of a parade. The 2 cables attached on the side of it makes angles of 48 and 40 degrees with the ground. If the cables attached to the ground are 10 feet from each other, how high above the ground is it? So again, this is a 3, is it? 3. Okay, that didn't work out. Try this again. Okay, so this guy was 10 feet apart. This is 48 degrees. This guy was what? 40 degrees, was it? And then we want to know the height here, right? We want to know h. Okay. Again, we do not know this guy. So we're going to call this guy D. So I have tangent 48 degrees is equal to h over d plus 10. Tangent 40 degrees is equal to h over d. Right? And I'm trying to solve for h. Yes?
In the book, they have like 40s outside and 48.
Oh, yeah, that makes sense, right? Why does that make sense? Because this is a smaller angle, this is a larger angle.
Just want to make sure. That changes the
Thank
diagram.
you. 40, 48.
Make sure we pay attention.
Okay, so let's go ahead and do the on this one, you would actually just kind of multiply, just get rid of this, right? Like that. Right? And then you can set this guy and this guy are the same, right? So this guy's gonna be equal to d tangent 48 degrees, right? We would solve for d, right? So you're gonna have 10 tangent 40 degrees plus d tangent 40 degrees is equal to d tangent 48 degrees.
Oh, let me digest that.
I just undid the parentheses, is all I did.
Okay.
Okay. Move this guy over and pull out the D. Right? We good? I just moved it over, pulled out the D because it shares the D. I divide it now by this, right? That's going to equal to D. Right? So once I find the D, then I should be able to put it in on this guy here. And I have H is, tangent 48 is H over D, right? I can figure out what H is that way. Okay? All right. Number 3. Let's do one more.
What's that laugh for?
Okay, this laugh is because I'm going to tell you something right now. Okay, and it's going to be, I'm going to tell you it's on the test. All right, and half of you are going to get it wrong. Okay, so here we go. Here we go. Example number 4. Example number 4. Okay, we have using trig in navigation. Normally, this comes into the form of boats traveling in the ocean, airplanes traveling in the air. Okay, just kind of setting the stage here.
What about cars?
Cars, usually not. Okay, so U.S. Coast Guard patrol boat leaves Port Cleveland, averages 35 knots. Okay, traveling for 2 hours on the course of 53 degrees. It says course of 53 degrees. So normally you would assume, well, okay, so go from here 53 degrees and it's going to go this way. This would be a bad assumption. Does not happen this way when you are navigating. When planes are flying, when boats are traveling, you always start from the north and you move clockwise. Start from the north, right? North, starting clockwise, you're going to go this way. So actually, if this is Cleveland, okay, it's going to go here, and this is 53 degrees. Okay, so you see the difference there? when you're navigating, you start from the north and you go clockwise. So it goes this way for 2 hours. And then what? It makes a course correction. And then it goes on a course of 143 degrees. Again, start from the north, 143 degrees. 100, so you go from here, 143 degrees all the way down. So it looks like it's going to be something like that.
Oh.
So this here is going to be 143 degrees. And how long did we go on that one? 3 hours.
35 now.
3
Miles
hours.
per hour.
Okay, so the question is, what is the question? What is the boat's bearing and distance from? So I want to know, in the end, I want to know the bearing. So it's going to be, I want to know this angle. It's an angle from here to here. And I want to know the distance.
Okay, so
Okay, so this is kind of tricky. Kind of tricky because if you look at these two parallel lines, this is 53 degrees, which means that this guy here is going to be 53 degrees also. What is the angle between here and here?
37.
It's going to be 180 minus 143, right? Which is going to be 37 degrees. Thank you, Sam. Good answer. So what do we have? Oh, look at that. It's 90 degrees. How lucky can you get?
2 lucky. That means it's 5.
Well, how else would you do it if it wasn't?
That's the next question. I will be asking that question to you. Okay, so it went 2 hours at what? 35 knots? 35 knots per hour. So actually, how far did it travel? It traveled 70 nautical miles.
70.
2 times 35. And over here is 105 nautical miles, right? Okay.
Okay, count.
So since this is 90 degrees, all I'm looking for is the hypotenuse, right? So the hypotenuse is going to be equal to 75 squared, 105 squared.
Is it 70 or 75?
70, I'm sorry, 70. Right?
126.2.
126.2 says Ezekiel.
126.
Okay, so in order to know the bearing from here to here, okay, I know this is 53 degrees. Now I need to find this guy here, don't I? So we'll call that X. But I know that tangent of X is equal to what? 105 over 70, right?
Nice.
So I can do the arctangent to find this angle here. So the bearing is going to be that angle plus the 53 degrees, correct? Are we good?
So like 56.
What was X? What was the tangent of, what was that angle? Did they look at that way? Yeah, I think you used theta, didn't they? Yeah, it's 56 degrees. So this guy here was 56 degrees, which means that the angle, the bearing was going to be what? 109.3 degrees, right? So I have to add the 53 degrees. So because I'm starting from the true north, and I'm going down that way, right? Right? Because the bearing is from here all the way down to here. And the length, how far away I am is right here. Okay. So Brady brought up a very good question. What if this is not 90 degrees? What if this happened to be 88 degrees instead of 90? Then how would you figure out what this angle is, this length is? Okay, you've learned this very briefly in geometry, how to do this.
Oh.
It was called the law of cosines. Okay, you did the law of sines and law of cosines. Okay. I'm not gonna go over it here because we're gonna actually do it in chapter 5, I believe. Is it chapter 5?
And then J,
Yeah, so the one on the test is gonna be 90.
5 of 5.6.
better Mr.
5
Owens
points.
is the struggle. That's how we said 1.5 is zero.
Law of sines and law of cosines. You guys remember this? Law of sines was sine A over A is equal to sine B over B is equal to sine sine C over C. You guys remember this?
Yeah.
Does this ring a bell?
Yeah.
Okay, and the cosine A was equal to A squared plus B squared minus 2AB cosine.
Oh, yeah.
Remember this?
That's familiar.
Okay, this is kind of stuff that we're talking about here, okay? All right? But we will go over that again in 5.6. Just so hang on to your horses there, okay?
Yes, yes.
All right, we'll stop right here for the first half and then we'll continue on the second half.
It's been real fun, Mr. Ron. It's been great.
It's been great.
So the